we're going to look at integrating trig functions of sine x and cos of x. So you will see that if you integrate cosine of x, you will get sine of x plus c. And if you integrate sine of x, you are going to get negative cosine of x plus c. Now, just as your general integrals. Here, these two formulas are given on your formula sheet, so you don't need to memorize them, but the more you practice them, the more you probably will memorize them. So if we look at an example, okay, so we want to integrate 5 sine x plus 2 cos x in terms of x. So here, we'll integrate each term separately, just as we normally would. So let's look at 5 sine of x. Well, I want to integrate my sine of x here. We can think of this as my constant value multiplied by my variable. So my sine of x, well, when I integrate that, it becomes negative cos of x. So here, I'm going to have 5 times negative cos of x. And I'll integrate my 2 times cos of x, so plus 2. Well, let's look at my cos of x. When I integrate that, that becomes sine. So sine, so 2 times sine of x. And then I'll put my plus c, because this is just a general integral. Sorry, an indefinite integral. So now I can just simplify this through. So this will be, or multiply this through, I have negative 5 cos of x plus 2 sine of x plus c. There, I've integrated, and I have my indefinite integral. So we're going to look at another one. Now, this next question, leave that up there so you can see it. Okay, you may want to pause the video and give this one a try. All right, so now we're going to find the definite integral. All right, so we'll integrate it using our trig functions and then find the definite integral. So I would pause the video and give it a try. All right, so looking at this one, what we want to do first is integrate it in terms of x. So if I integrate 4 cos of x, I'm going to have, so cos turns to sine, so I'm going to have 4 sine of x plus 2 sine of x. When I integrate that, that will become negative cos of x. So this will be minus 2 cos of x. And we want to find it in between the limits of 0 and pi over 4. So we're in our radians here. So we'll separate this into our 2 brackets. So we're going to have 4 sine of pi over 4 minus 2 cos of pi over 4 minus 4 sine of 0 minus 2 cos of 0. Now, when you're looking at this, be very careful, okay? Because this is not just going to necessarily end up at 0, okay? So let's work these out. Well, we have 4 sine of pi over 4. Well, pi over 4, where should I put this? Let's put this over here. So we know that pi over 4, right, is our 45 degrees. So we want to find the exact values of 4 sine pi over 4. So if I have a little exact value triangle, my right angle triangle, so we know these would both be 45 degrees. So we have on our isosceles right angle triangle, both 1, and when I use Pythagoras, so 1 squared plus 1 squared, and then take the square root of it, the hypotenuse becomes the square root of 2. So you can either memorize your exact values or use the right angle triangle, however you want to work it out. So now when we work this out, we know that we have 4 times, well, sine of pi over 4. So sine, we know, is opposite over hypotenuse. So if this is my angle, we have opposite over hypotenuse. So it's 1 over the root of 2 minus 2. Now cosine pi over 4. So adjacent over hypotenuse. So adjacent over hypotenuse. So 1 over the root of 2. And then when we subtract this, well, we have 4 times sine of 0. So we can look at and think about our graphs, our cosine graph and our sine graph. So when sine is 0, it's 0. And then when we look at our cosine graph, we have when cos is 0, it's 1. So here, this is going to be minus 2 times 1. So let's simplify this. We have 4 over the root of 2 minus 2 over the root of 2 when I multiply through the brackets, and then all that minus 2. Oh, plus 2 actually, so it's minus, I'll do negative 2 here, minus negative 2, because within the brackets it's a negative. All right, so now simplify it a little bit further. Add these fractions, 2 over the root of 2 plus 2. So what I want to do here is I want to rationalize my denominator. I do not like a denominator with a root. I also want to add these together, so I'm going to rationalize the denominator. So when I'm doing that, I am multiplying this fraction here by the root of 2 on the numerator and the denominator. Going back to some National 5 work. So we have 2 times root 2 on the top. Root 2 times root 2 just gives me 2. And we have plus 2. So now, when we look at this, we can simplify, and we have 2 over 2, so that's just going to give me root 2 plus 2, because I can cancel those down. And there, that is my definite integral for my function.